Hi, I'm Chris of Tag Optics, a business partner of Mitutoyo Corporation. We are here today at Automate 2017 at McCormick Place in Chicago, Illinois. And I would like to show you a couple of the demonstrations for up-and-coming product by Tag Optics and Mitutoyo partnership. In this first demonstration, we showcase the power of the tag technology along with the Mitutoyo telecentric objectives. Specifically, the tag technology enables us to change focus in millionths of a second. In fact, our theoretical frame rate limitation is about 3 million. Now, of course, cameras today cannot achieve this speed. So we're doing the next best thing, and we paired it with a camera that can operate at about 180 frames per second. Now, the inspector itself is composed of the camera, the tag lens, a couple additional optics, and the Mitutoyo telecentric lens. It is entirely controlled by the Tag Optics driving electronics, which synchronizes the light source, the camera, and the lens all together. This then enables us to do what we call frame-by-frame focusing, which means that every frame of the camera, as fast as the camera can go, will be at a different focal location. The result, as you can see on the screen, is 3 separate focal locations generated by one optical system, all at the same time. Specifically, in this case, we're talking about 60 volumes per second, since each frame is refreshed 60 times per second. The Tag Optics Inspector just received at this trade show the Gold Award from the Vision System Design Innovation Award for 2017. In the second demonstration, we are showcasing the Tag Optics Zip prototype. In this case, we're applying our technology for a much more large field application geared towards machine vision, 3D scene inspection, and robotic guidance. Specifically, instead of gearing our technology with a micro lens, we actually added a camera lens to it. This then enabled us to go from a standard depth of field of millimeters to centimeters to meters of depth of field. This then enables us to do frame-by-frame focusing by pairing the system with a camera that can operate up to 360 frames per second, so that we can then arbitrarily choose various focal planes to inspect in real time. Specifically in this application, or in this demonstration, we are showing 5 focal planes perfectly in focus simultaneously. The first 3 focal planes are focused on inspecting the vial as it passed at the nearest part of the camera. In fact, the first image looks at the front of the vial, the second image at the center, and the third image at the back of it. This information would then enable us to actually recreate a full 3D information and a full 3D model of the vial in real time as it goes across. Now, of course, given that our technology is so fast, we can also continuously inspect other areas of interest in the volume. So in this case, the fourth image is actually looking at the vial in the back as it comes across. And finally, the fifth image is looking at infinity, enabling us to actually see any object that would be approaching to the 3D reconstruction scene, or for example, if this was a robotic application, for robotic guidance and robotic automation, the Tag Zip can actually enable a lot more precise pick-and-place location. Specifically, thanks to the progressive nature of the depth of field of natural physical optics, using the tag lens and the Tag Zip, we can actually generate XYZ information for every in-focus element. Meaning that as the robotic arm comes closer and closer to the part to pick, it will know at higher and higher resolution the location in X, Y, and Z. Meaning when the part's at infinity, it will have a rough idea where it is within meters. When the part is getting closer, it's going to start knowing its location in Z within centimeters. And as the robot starts to hone in on the part, it will actually start to get millimeter and eventually sub-millimeter accuracy to really be able to detect and pick up the locations of the part with very high precision and lots of delicateness.